Hello everyone, my name is Rishi. Today I'll be presenting my task, which was building a data export engine capable of asynchronous streaming millions of database records into a CSV file without crashing or consuming excessive memory. So for the tech stack, I used Node.js, Express, PostgreSQL, and then Docker, and then PG Cursor for the database streaming, and the fast CSV for optimal file writing. So the main problem I solved it that standard RSJPS is usually crashing out with our out of memory errors when exporting massive datasets like 10 million rows because they try to load everything into the RAM at once. I solved this by building a memory efficient streaming pipeline that respects a strict 150 MB container limit. This is a massive real world use cases in SaaS and CRM and or for example like e-commerce platforms where admins needs to export years of data similar to Salesforce backups or Shopify order histories. So uh, for sorry. Okay, so what happens is what I have designed in this architecture is so uh, first of all we have the main issue is uh, i- uh, if a user wants to export 10 million of rows into as an CSV folder, CSV file, then it would crash with out of memory errors. So to fix this errors, I have solved this by using this method where I have used like I have used the streaming like services like so this sends the data in a constant rate uh, like streaming. So this would help the data to sorry sorry again. So this would help the data to export millions of rows in a memory efficient way. So let me start up the environment to show how the system works. While the database seeds, while the database seeds, see you can see right. This is the initial SQL what I have written here. So here, this would generates a random 10 million rows. So I have written I have used a CTE here, commentable expressions and cross joins to just generate a series of numbers, and then this would take around some of the time like to generate because it generates large sequences, right? So the Postgres so the benefit with Postgres is here the Postgres 15 version 15 allows us to easily generate large sequences of data. So here what happens is next first the client sends a post request to the exports slash CSV endpoint. Instead of making the user wait, the API returns a 202 accepted response with a unique export ID. So this starts a background job. This approach unblocks the main API thread. So what happens here is when the user requests to export the data, then the then we the API will immediately send a response by using the 202 acceptance error. So that instead of 200, because 200 is a complete success where the data has been completely fetched or exported. So here we have accepted the request from the user, and then we started exporting the rows in a stream. So let me show you with the postman. So see you here I have written like request CSV, right? So let me send this. So here you can see like here we have got the response as to not to accept it. and the export id and status as pending. So let me copy this export id. Okay, so now the client can then pull the exports slash export id slash status endpoint to see the processing percentage. So I have written the endpoint here. So in this I have created a variable where directly we can change. So in this method we can see, so here you can see like 13% of the data has been completed exporting. So here we can continuously we can send the request, and we can find out the percentage of processing percentage. So behind the scenes, what happening was, uh, I'm using a pg cursor to stream rows in a batches of 2000 into csv parser. So this strictly monitors back pressures. So what happens in the back pressure is, so the data starts being transferred to the server into a high speed. So but while streaming, it might have a slow speed. So what happens in this case is, so this would create a back pressure. So to solve, I have solved this issue by using the pause and drain. So I have created by I have created a buffer. So in this when the receiver when the sender sends the data into a buffer, when the buffer come will when the buffer is completely filled, then the receiver would send a request to the sender that uh, wait a second, like he asked for a pause, so that after completely exporting it into his local system, then again he asks for the drain. So he actually sends a response to the sender like drain. So what happens here is, all the data was imported, so again you can fill this bucket and you can give it to me. So this what happens. So this ensures that we only hold a tiny chunk of data in memory at a given nanosecond. So once it hits 100%, the client hits the download button to get the file. Okay, so now let us check the download percentage now. So still it has been uh, exporting. So now already I have completed this process, and I have already completed previously. So because it takes some time, right? So meanwhile, let me show you my code. Okay, so coming to my code, uh, my project is split between the docker config and the database seeds and the src folder containing the API logic. Okay, so the in my docker hyphen compose.yml file, you can see here I have limited the memory to 150 MB here. So what this makes is, the node container to prove the streaming work guarantees work. So here we are transferring the data in a constant limit, like it is allocating only 150 of ram 150 MB of ram, and within this 150 of ram, the data is being exported, and it is not consuming any other extra limit. Okay, so and here in the seed file again, you can see I have used the generated series to create a mock data. So I didn't use any data sets already which were in the online. I have just written this to generate like random data, and later the core logic I have written is here in the jobs.js. Yeah, sorry. So here you can see this, right, in the process export job, I have written the main logics. So I use a client query, which is like new cursor, right? Here you can see, right? So I don't load everything at once, and then I use csv.stream.py of a file stream to handle the data flow. So and then next, the hardest challenge in this task was managing Node.js stream backpressure. Even with streams, if you pipe a fast database reader to slow to a slower file reader, file writer, the internal buffers fills up and memory inflates. So while I was writing while I'm working with this project, I have initially only written only to export the CSV file by using only the streaming methods. So while I'm streaming, I have faced many errors like back pressures, and some of were like memory out of memory limit, and like that. So I have again changed that to 150. Initially I have written like 250 and 100, like that, while I'm working with that. Later on I have again fixed with 150 MB, and then again I have started writing this uh, csv.stream, so that to solve this I set up to a listener on the csv stream boolean. So it returns values. If writing to the file streams returns false, meaning the buffer is full, I temporarily pause reading from the Postgres SQL cursor. I then wait for the file stream to emit a drain event before fetching the next 200 rows, 2000 rows. Sorry. Uh, this back pressure handling is the secret to staying under the RAM limit. As you can see here in the Docker stats, wait, let me show you. Yeah, yeah, here you can see in the Docker status, doing that with like Docker hyphen log. Yeah, so here you can see this, right? I have allocated memory RAM usage with limit 150 MB. Okay, so y- to wrap up, there are a few limitations I had like to improve in the futures. Currently, in the background, job queue lives in the memory. If the container crashes, running jobs and the stats users are lost. Also, saving files locally on the container file system means this won't scale horizontally with multiple servers. For the future scope, I would shift the job state management to a persistent stores like Redis. So I would also stream the generated chunks directly to the cloud object storage like AWS S3, using the multi-part uploads instead of relying on local disk space. So yeah, now let me. I think the conversion has been completed right now. Okay, so actually I have reloaded, I have restarted it, right? So I think it it got stuck. So this is the main problem what I have facing is. So if that container gets stopped running, then it would stop this running all this like I have you have seen this, right? Already it has been completed 60% of the work. But when I have stopped the container, then it again erases all those things. So to manage the sessions, I would like to use this Redis in the future implements. So I have already run this previously, and the output what I have got is this one. So now let us see this. So you can see this, right? Here these are the random names and values. So here you can see this 10,000 rows. Okay, yeah, these are the 10 million rows what I have exported. Yeah, so thank you for watching this video.